All right, let's dive into two invisible forces that are, and I mean this literally, running the entire universe. We're talking about everything from how planets stay in orbit to, well, to why you can stick a balloon to a wall after rubbing it on your head. They are everywhere, they are fundamental, and today we're going to see how they stack up. So think about it for a second. We all get gravity, right? It's the reason our feet are firmly planted on the ground and we're not just floating off into space. But what about that party trick? You rub a balloon on your sweater and poof, it sticks to the wall, almost like magic. Well, that's a whole other invisible force at work, and it's one that can actually beat gravity. So first up, let's tackle the big one, the heavyweight champion of forces, the one we feel every single moment of our lives. It's time to open our first case file, gravity. So what exactly is it? Well, in the simplest terms, the gravitational force is this pull that exists between any two things that have mass. And I mean any two things. You, your phone, the earth, the sun. If it's made of stuff, it's got gravity. And here's the secret sauce for gravity. It all comes down to mass. That's it. The more mass something has, the bigger its gravitational pull. It's why we feel the Earth's pull so much. But you don't really feel the pull of, say, the coffee cup on your desk. The Earth just has a ton more mass. But, it's not just about mass. The strength of gravity really depends on two key things: how massive the objects are and, how far apart they are. So more mass means a stronger pull, but more distance makes that pull weaker. It's this constant cosmic dance. And here's the one rule about gravity you absolutely have to remember. It never, ever pushes. It only pulls. It's always an attractive force. It just brings things together, whether that's an apple falling from a tree or entire galaxies clumping together across the universe. And you don't need a fancy lab to see this for yourself. The best demonstration is super simple. Just drop something. Anything that falls is a perfect real-time example of gravity doing its thing. It's happening all around us all the time.
Okay, so I think we've got a pretty good handle on gravity, but that still doesn't explain our balloon mystery, does it? For that, we need to investigate a completely different kind of force. So let's open up case file number 2, electrostatics.
So what's the deal with this force? Well, it all comes down to something called electric charge. And you got to pay attention to that keyword right there. We've just switched from talking about mass to talking about charge. And believe me, that changes everything. And this right here is the absolute core difference. If gravity's secret ingredient was mass, then for electrostatics, it's all about charge. Those little positive and negative particles that make up pretty much all matter. See, unlike gravity, electrostatics is not a one-way street. It actually plays by two really simple but super powerful rules. First, opposites attract. So a positive charge and a negative charge, they'll pull toward each other. But, and here's the twist, likes repel. Two positive charges or two negative charges will actually push each other away. So it can pull and it can push. Which brings us right back to our balloon. When you rub it on your hair, you're loading it up with a negative electric charge. That charge is then strong enough to pull on and attract little things like tiny pieces of paper. What you're seeing is electrostatics overpowering the force of gravity right there in your living room.
All right, we've met our two contenders. We've investigated both of them. So now, it is time for the main event. Let's put these two invisible forces head-to-head in a direct comparison. It's time for the force face-off.
Okay, let's break it down. What's the source? For gravity, it's mass. For electrostatics, it's electric charge. What kind of force is it? Gravity is always attraction, no exceptions. But electrostatics, it can both attract and repel. Who do they act on? Well, gravity acts on everything with mass. Electrostatics only cares about objects that are charged. And the perfect examples? A falling apple for gravity and that charged balloon sticking to a wall for electrostatics. Pretty clear, right? So we've got these two different invisible forces, and they play by different rules. But so what? Why does any of this actually matter in the grand scheme of things? Well, let's connect all these dots. It matters because these forces basically run the universe on completely different scales. Gravity is the master of the huge cosmic stuff. It's the force that keeps the moon orbiting the Earth and holds entire galaxies together. But electrostatics? It's the master of the microscopic world. It's the force that holds atoms together to make molecules. It's the reason we have chemistry at all. It's the glue of our world. And it's also why you get that little zap when you touch a doorknob. And that leads us to one last kind of mind-blowing question. If Earth's gravity is strong enough to keep the entire moon locked in orbit, how on earth can a tiny bit of static on a little rubber balloon overcome the gravitational pull of the entire planet to lift up a piece of paper? The answer tells you something amazing. On a small scale, the electrostatic force is ridiculously, unbelievably stronger than gravity. These two invisible forces are in a constant, hidden dance all around us. And now, you know the steps. Thanks for joining me.